All right, so in the class before, what we looked at was metric measurement, which again was what we use in Canada. But now we're going to look at something a little bit different and older, in which that is called imperial measurement. Now, imperial measurement is what's used in the United States. It is based on a system of years and years ago. And in fact, it is a system that tends to be based on familiar objects to people many, many years ago. Such as feet, which we still hear of, feet up there, hands, chains, stones, teaspoons, a whole wide variety of measurements. Wingspan, they used to use that. The problem was that everybody has a different size foot. Everybody has a different size of hand. There's different size of stones out there. Spoons back then, I mean, they're hammering it out with a cast iron hammer. They're not the same size. And so everything was, that's why the metric system did come along. But imperial measurement, because it was basically the first organized system around, still today we have to deal with it. And it, like I said before, with construction, even in Canada, just about everything is imperial. Wood and the measurements in a house and all that kind of thing is mostly imperial measurements. So now, like I said before, not like imperial metric measurement, which was easy because you're always multiplying by a multiple of 10, either 10, 100, or 1,000, or dividing by 10, 100, and 1,000. That's not the case with imperial measurements, and that's what makes it harder. All right, so and that's why you have that conversion sheet that I did put out in Google Classroom and that I am going to use, because that is something we are going to need. All right, so on that note, here we go for a few examples. I'm going to make sure my whiteboard doesn't do a spin here or a fly. All right, so there we go. So our first example is that I'm going to convert, we'll call this example 1 here. Part A is I want to convert 54 inches to feet. All right. So here's what we're going to do. We're going to set up a table. All right. Now, our table is going to look like this. I'm going to draw 2 lines. Well, I'm going to draw more than 2 lines, actually. But we're going to put 1 here and 1 here. All right. Now, once in the middle here, what we're going to put in is what units we're working with. Now, in this case, we're going from inches to feet. So I'm going to put inches in here, IN, and feet, which is commonly short formed of FT. Now, in our case, we have 54 inches. So I'm going to put a 54 right here. I can put it right here. Doesn't matter. I want to know how many feet it is. So I put an X. Now, here's where our table comes into play. All right, our conversion sheet. So what I want to know is the relationship between inches and feet. Now, on this sheet, I look at it, and I'm just looking at here, length down at the bottom. It says I got inches to centimeters. That's not helping me out. What about feet and inches? Oh, right here in the middle, imperial system. It says 12 inches is 1 foot. All right, so again, this is why I put my units in the middle here so I don't get things mixed up. So the 12 goes in here. 12 inches is 1 foot. That's the hardest part about this today, is getting the table down. All right, so now I have it set up. Now what I'm going to do is I'm going to take this table, and it's actually an equation. And here's how it works. This is a fraction. I get 54 over x. I'm going to put a 54 over x. It's equal to, I got a 12 on the top and a 1 on the bottom. So I have an equation here where I have a fraction equaling a fraction. Now here's the trick on making this a lot easier and get rid of the fractions. Is what I'm going to do is I'm going to cross multiply. Which means I'm going to go x times 12 which is 12x, equals the other part of the cross multiplying. 54 times 1. Well, anything times 1 is just itself. So 1 times 54 is 54. All right, now this is where we get into solving equations. Hopefully you got a little bit of experience with that, but we are going to go over it. I want to get x by itself, right? I want to know how many feet we got here. So to get rid of this 12, I can't move it because it's attached, but I can divide it off. And what I do to one side, I do to the other. And so these 12s cancel each other out or divide each other out, I guess is the proper terminology. And my number here is I've got 54 divided by 12 is going to tell me how many feet I have. So I'm just going to grab my trusty calculator here and I type it in. And it looks like I have 4.5 is my answer. And again, I need to put the units. What was I looking for? Well, my table tells me what I was looking for. I was looking for feet, the amount of feet. There we go. All right, so again, just to kind of recap our steps, we write down what we're looking for here, the units we have we're dealing with, and then the relationship between those two units. Now, some people put this first and that over here. It doesn't matter because when you set up your fraction, you do cross multiplying, you get the same thing. All right, so now I'm going to go B. What else are we going to try here? Convert 2 miles to yards. 2 miles to yards. All right, so just as I did before, I'm going to set up my table. All right, so I'm going to draw a line across here, put 2 down the middle. All right, so now I need to pick where my units are going to go, all right, to sort things out. I'm dealing with miles and yards. So I'll put my miles up top here, MI, and yards usually is YDS, yards. You can write the full name, doesn't matter. I just have I don't have as much room as you do. All right, now we have 2 miles. So miles is up top here. I've already said that. And I want to know how many yards. So I'll put an X. All right. Well, now out comes that conversion sheet again. All right, so I look. Length, again, down at the bottom. I'm dealing with the imperial system. All right, so then I look at the relationship between miles and yards, and I find out here that 1 mile, so I got 1 mile, is actually equal to 1,760 yards. All right, so there's the conversion there, or the relationship. All right, so again, I'm going to rewrite this table now as an equation. It's going to be a fraction equaling a fraction, which we are going to encounter quite a bit in the next few weeks. So it's good practice here. So I have 2 divided by x, right? 2's on the top, x is on the bottom. Equal to, I got a 1 on the top, 1,760 on the bottom. All right, now, again, when I have a fraction equaling a fraction, the best way to deal with it is to cross multiply. Gets rid of all the fractions for us. So I'm going to have my first part here is x times 1, or 1 times x, however you want to look at it. Either way, when you multiply something by 1, it's just itself. We'll get an x. But then it equals the other part of the cross multiply, which is the 2 times 1,760. All right. Well, now I can just solve that. Here we had to divide, but this time we're multiplying. That happens. You can have one or the other. You're going to have to divide as your last step, or you're going to multiply as your last step. In this case, it looks like we're multiplying. And it's the odd time. You got to do both. All right. So then I get 2 times 1,760, and I type that into my calculator here. And I get 3,520. And again, because if you write out all the steps, what are we looking for? Look up here, x, yards. We want to know how many yards. There we go. So 2 miles is 3,720 yards. All right, let's try another one of those before we step it up, get a little bit harder. So C, we're going to convert, let's see here, try some weight. I'm going to convert 20 ounces to pounds. All right, so 20 ounces to pounds. So again, I'm going to set up my table, draw my line there, and then 2 down the middle. All right. So again, I know the units I'm working with, ounces and pounds. And ounces is usually OZ, and pounds is LBS. Again, you can write in the names if you want. Now, we're dealing with 20 ounces. So again, ounces on the top, so I got to make sure I put my numbers in the right spot. And we want to know how many pounds that is. So put an X. Now, again, for the other half of it, this is where I go to my sheet here. And let's check it out here. So ounces to pounds. Oh, we're down to mass, right? Yep. And it says, again, if I look under Imperial system, which is down the middle here, 16 ounces in a pound. Okay. 16 ounces in a pound. So ounces, again, is on top. Our chart sorts it out. 16 ounces in 1 pound. All right, so again, that is an equation. That table sets up an equation for me. All right, so I got 20 over x is equal to 16 over 1. Essentially, when I create that fraction equaling a fraction, I'm just writing down the table, but getting rid of all the units and lines. That's all I'm doing. But again, just as I did before, I'm going to cross multiply. All right, so this time I get x times 16. Well, or 16 times x. Doesn't matter when you're multiplying the order. All right, so 16 times x would give me 16x equals the other part of our cross multiply, where we get 20 times 1. Well, 20 times 1 is 20. All right, so again, I got to get x by itself here. This time it looks like we're going to have to divide for our last step. All right, so 16, well, to get rid of 16, I got to divide it because it's attached to the x. What I do to one side, I got to do to the other. All right, so I'm going to divide the other side by 16. Now these 16s divide each other out, and what I'm going to be left with is our answer. So 20 divided by 16, I get 1.25. And again, what did I find out? Well, my table tells me if you have a look, the x down here, the units were pounds. So 20 ounces is 1 1/4 pounds, or 1.25 pounds. All right, now we're going to get to ones where it's a little bit harder, and I'm going to explain why they're harder. All right, so we're going to try a couple of those. Give me a second here to wash things down, make sure my board doesn't go flying. I'll hold it in place. Make sure it's nice. All right, let's see here. Smooth it all out. I want to wreck my smartboard marker or my markers. All right. So the next one here is I'm gonna go with example 2 because these ones are different. All right. So A here, we're going to convert. We got this time 3 miles into feet. All right, now, here's why I'm going to say these ones are tougher that we're going to do here. Because the first thing I'm going to do, and this is probably maybe your first step you should look at, is when I grab my conversion sheet. Miles into feet. Now, when I look on my sheet, oh, I do have miles into feet here. What the heck? Okay. Maybe this one isn't tougher. All right. Well, hey, we'll do this one then. All right. So we'll go into miles into feet. See if there is a conversion. I just found out there actually is one, so I might as well do it a little bit differently. So let's see here. Miles. I look on my sheet. So again, we're going into miles into feet. All right. And we have 3 miles. And we want to know how many feet. All right, and now let's see here, the conversion here. So again, I got to look at the sheet. Always check to make sure there actually is one, because in my next example here, there isn't going to be one. All right, I hope there isn't. That's the way I planned it anyway. So 1 mile is actually, so I'll put a 1 up here, 1 mile is equivalent to 5,280 feet. All right, so now I'm going to convert these two, all right, in this table into a fraction. So I got 3 over x equals 1 over 5,280. All right, so once again, we are going to cross multiply, right? So I have x times 1 or 1x, or 1 times x, same thing, we get an x. And then that's equal to the other side of our cross multiplying, which is 3 times 5,280. And let's see here, we get some bigger numbers here. I get 3,000 times 5,000, or 3 times 5,280, and I end up with 15,840. And our units here, we just found feet. There we go. There we go. All right, now, again, I'm going to step it up here. I said that last time, but this one actually is going to be, better be anyways. Let me make sure when I look at, okay, yes, beautiful. All right. Now, B is we're going to convert, let's see here, convert, wrote a little bit differently on my sheet, 10,000 ounces to tons. All right, now, yeah, I'm going to draw my little table here. But again, the first thing I'm going to do is see if there is a relationship here. Sometimes there isn't. This is what's going to happen in this last example here. I look for ounces and tons. And you look under mass, under Imperial system. It's in the middle of their chart here. You can see it right there. All right, now you'll see that there is no ounces to tons. But I can convert ounces to pounds because there is a relationship between ounces and pounds, and then there's also a relationship to pounds to tons. So what I'm going to do is convert these ounces to pounds first, and then I have to do it all over again here. I'm going to convert those pounds to tons. So because there's no relationship between ounces and tons, I got to do it twice. All right. So we have 10,000 ounces. I don't know how many pounds that is, but I do know a relationship between ounces and pounds. All right. It's on my sheet. And the amount of ounces that we have are 16 ounces in 1 pound. All right. So now, again, just like I did before, I'm going to create a fraction equaling a fraction. So I get 10,000 on the top, x on the bottom is equal to 16 on the top, and a 1 on the bottom. Once again, I'm cross multiplying. All right, so I got 16 times x. That's one side of my equation. On the other side, I'm going to have 1 times 10,000. Well, 1 times 10,000 is 10,000. All right, then I got to get x by itself. And so it looks like this time we're going to be dividing. I got to get rid of that 16. The only way to do that is to divide both sides by 16. And now I take 10,000 divided by 16, and I'm going to get, let's see here. Oh, wow, round number. 652 pounds. All right, but that's not what we want our ounces in. We want our ounces to tons, right? We didn't have a relationship from ounces to tons, so we're going to have to kind of bridge it over. So now I know that 10,000 ounces is 652 pounds. So I'm going to put that right in here. I know now that we got 652 pounds. We want to know how many tons there are. So now I can go back to my conversion sheet again because I'm just redoing the steps that I did before. I'm looking at the relationship between pounds and tons. All right, and it looks like 2,000 pounds is 1 ton. Well, I guess that makes sense. It's big. So 2 again, because I have my top and my bottom labeled, I know where to put things. Pounds is on the top here, so 2,000 of these pounds is 1 ton. Okay, well, now just as we've done before, I'm going to create a fraction equaling a fraction here. So I got my 652 is on the top, divided by the x is equal to the other side there where I have a 2,000 on the top and a 1 on the bottom. Okay, and just as we've done before, I'm going to cross multiply. And so I have 2,000 times x. Well, that's going to be a 2,000x. That's equal to the other part of the cross multiplying, which is my 652 times 1. Well, anything again times 1 is just itself. All right, and let's see here. Well, the final answer here, I got to get rid of this 2,000 because, again, I want my x by itself. And because it's attached there by multiplication, I got to divide both sides here by 2,000. And it looks like x is equal to whatever 652 divided by 2,000 is. And I end up with 0.3125. And again, our final answer, what we're looking at is in tons. So again, most of these are 1-step, but you do have to watch out that some of them could be 2-step. But again, the key thing is to use your sheet to make the conversions, to figure out what the relationship between your units are. I guess your first step is to find out what units you're messing with, what you know, what relationship there is between the two, and then, of course, setting up your equation, which is going to be a fraction equaling a fraction. And then when you cross multiply, the fractions disappear. And again, that is a skill we're going to use for a different topic, but we're going to use it quite a bit in the next couple of weeks. All right, so again, that is why imperial measurement, as you can see, much, much more complicated than metric measurement, and hence why we have metric measurement, because when it was invented in 1790, we didn't have calculators, so they just weren't able to easily just punch numbers in. So it was even more difficult for them. So they had to be able to just use zeros only. Multiplying by 10, 100, 1,000, or dividing by made things easy because essentially all you're doing is moving the decimal place.